All right, warriors, this is Algebra 1. We are in Chapter 6, Lesson 4, Exponential Growth and Decay. Our essential question, what are some of the characteristics of exponential growth and exponential decay functions? Now, before getting into this, I just want to remind you, actually, not remind you because you weren't even born yet. So let me tell you a story from my childhood. We used to watch this thing called television. And when you watch television, there were commercials. And there was this one commercial for this shampoo that would come on all the time. And it would start with this one lady holding the bottle of shampoo. And then she was talking about how great the shampoo is. And she said, and I'll tell 2 friends, and they'll tell 2 friends, and so on, and so on. And as you can see from the pictures here, more and more people would show up on the television screen. Now, the commercial didn't exactly mathematically do it correctly. However, it did make the point about exponential growth, that some items grow very rapidly, very quickly. All right, so let's take a look at the definition of exponential growth. Exponential growth occurs when a quantity increases by the same factor over equal intervals of time. Now, previously, we were using an exponential function. We were using the function y is equal to ab to the power of x. All right, well, we're going to just make a few modifications to this equation that we were using. So we're still going to have y, and y is going to be equal to our final amount. And we're still going to have a, and a is going to be the amount that we started with, our initial amount. But instead of b, we're going to replace b with the expression 1 plus r. And the r is going to be the rate of growth. Now, rate is usually a decimal, so we'll have to change the decimal. Sorry about that. Rate is usually a percentage, and we'll have to change the percent into decimal form in order to use it in the equation. And that whole part right there, the 1 plus r, that's going to be called our growth factor. And then instead of x, we're going to have a t. And t is going to stand for time. All right, so this is going to be the new equation that we will work with in this section. So let's take a look at an example. I am in your textbook on page 314. This is example 1. So the inaugural attendance of an annual musical festival is 150,000 people. So that means that the very first time that they had this music festival, 150,000 people showed up. The attendance, y, increases by 8% each year. Write an exponential growth function that represents the attendance after t years. All right, so first, let's just copy down the equation that we're going to need. So y equals a times 1 plus r to the power of t. All right, it says write exponential functions after t years. So what do we know? We know the inaugural attendance. That is our initial amount. So when this started, there was 150,000 people. So let's say y is equal to 150,000. Okay, times 1 plus, all right, our rate, it says that our rate is 8%. Now we're going to need to change 8% to a decimal. So we're going to move the percent sign. We're going to squish it down into a little decimal and move it 2 places to the left. So that will give us 0.08. And then we're going to have to the power of t for time. Okay, so we just now need to simplify this a little bit. In our parentheses, I can add those two together. So I'm going to have 1 plus 0.08. That's going to be 1.08. That will be to the power of t. And then I'll have 150,000 is equal to y. Okay, so that gives us the equation that we need to work with. That takes care of part A. Now, part B. How many people will attend the festival in the 5th year? Round your answer to the nearest 1,000. Now, we have to be a little bit careful about this because the instructions say in the 5th year. Now, that doesn't mean 5 years later. If it had said after 5 years, we would just plug a 5 in for t. But it's saying in the 5th year. So our very first time that we had this festival, t was actually 0 because no time had passed yet. So in the 5th year means that we're talking about 4 years later that this event has taken place. So we're going to replace t with 4. And that's just simply, I know that's a little confusing, but that's just simply how this problem was set up. If it had said after 5 years, that would be different. But this particular one, t was 0 in our initial festival. Our initial amount of time would start at 0. Now in the 5th year, that means 4 years has gone by. So we're going to replace the t with a 4. So let's write y is equal to 150,000, 1.08, and we're going to put a 4 there. All right, so now we just need to take out a handy-dandy calculator and plug in our numbers. So we're going to have hang on a second, let me clear that. 1.08 to the power of 4 equals 1.36, and then we're going to multiply that. It's already in my calculator, so I'm going to multiply that times 150,000 equals, and it looks like I have 240,073.344. Okay, now we're talking about actual people here, so I can't have a 0.344 of a person. I'm not going to have a third of a person, so that means my answer is going to be approximately 204,073. Okay, let's go ahead and do another example. Monitoring progress. This is at the bottom of page 314. So a website has 500,000 members in 2010. The number of members increases by 15% each year. write an exponential growth function that represents the website membership T years after 2010. How many members will there be in 2016? Round your answer to the nearest 10,000. All right, so let's start by writing out our equation. So y equals a times 1 plus r to the power of t. Okay, so y equals, our initial amount is 500,000. So y equals 500,000 times 1 plus our rate. Our rate is 15%. So let's move the decimal over 2 places. We'll have 0.15 and to the power of t. Okay, so then all I have to do is add together the amount that's in the parentheses. So y equals 500,000 times 1, whoops, hang on a second, sorry about that, 1.15 to the power of t. Okay, so that gives us our equation needed. Now, let's look at the instructions. Now I like the way this problem is set up better because it says T years after 2010. So that's what we've set up. How many members will there be in 2016? Well, that's 6 years after. So now for part B, all I have to do is replace T with 6 because 2016 is 6 years later. So y is equal to 500,000 times 1.15 to the power of 6. Let's take out a calculator and let's put in 1.15 to the power of 6 equals 2.313. And that number is already in my calculator, so let me multiply that by 500,000. And I get about 1,150,000. Well, 156,000. Now it tells me to round to the nearest 10,000. Okay, so if I had 1,156,000 and I'm rounding to the nearest 10,000, I'm going to round up, so that's going to be approximately 1,160,000. So my answer is going to be approximately 1,160,000. Okay, and that takes care of example 1. In the next video, we'll talk about exponential decay.